Okay, that should be the recording on. So last time we were talking about user input. So basically how to interact with the code that we're writing. And since it has been 2 weeks from the previous meeting, it's probably good to recap some of the more important things. So this was the picture that I showed last time. So basically, when we started out with doing the classic hello world, that's all amazing and dandy, but you know we would probably want to have some way of interfacing with the program as well. So any sort of computer program, you have your user or you here on the left hand side. There's the program, and in between there are various inputs going toward the program, and in our context that basically means whatever you're typing in with using the keyboard, and outputs, that's whatever text in our case the program happens to be printing to the console. And again, we're mostly going to be focusing on text-based programs, although there is a module at the end that deals with graphical user interfaces. But anyway, for us, most of this interaction, it's going to be text-based. And how do you ask for input from the user? Well, in Python, very simple. The command is called input. And if you remember, the very first example of this looked something like this. So you need the input command, and you need some variable where you're going to store whatever the user types using the keyboard, and then afterwards you can use that variable to access whatever information was typed in by the user. Fairly simple, and well, fairly simple, and well, it turns out it is not very difficult. All you have to pretty much remember is whatever you're typing in using the keyboard, it's always always text. It's never automatically numbers. If you need to ask for numbers, then you need to do you need to deal with the data type and changing the type of that data. And shortly about that, I think on one of the coming PowerPoint slides. And shortly about the variables. So variables can hold all kinds of data, and for us, all kinds of data basically is two categories. It's either text data or numeric data. As demonstrated many times, we don't actually need user input to create variables. There are other uses for variables as well to store different things. So sometimes you might imagine that if you need to store a number, some constant number, such as the value of pi, if you are doing calculations having to do with pies, because pies are round usually, and in our context, for example, in the pizza calculator, in order to calculate the area of a pizza pie, you need the actual mathematical constant pi, 3.14, well, 3.141, and so on and so on. And sometimes it would make sense to store that constant not as a number, but maybe as a variable called pi. It might make the code a little bit more readable. So Well, anyway, the variable is a programming term that means to store some value in the computer's memory. Well, actually, what it is, it's you're storing the values into the computer's memory, but you're also giving them a name. So, and using that name later on, you can reference to that value in your code. And then we had this example here that, for example, imagine this program that greets people in many languages. We store some of those greetings in many languages using these variables. So on this left hand side, we have these variables, greetings in Finnish and Spanish and English. And then later on in the program, we can use those variable names to simply print the contents of those variables. So far, nothing new. This is this we went over last time in much detail, and if you did the exercises last time for what is called lesson 2 on the course page, then you probably have a very good grasp of what variables are. The only tricky part when it comes to variables is that there are those two types of different data. So there's numeric values and there is also text. So we distinguish in Python, we distinguish numbers from text. And when we are asking for user input with the input command, we're reading data from the keyboard, and the keyboard can contain both numbers and number and letter keys. So obviously we can't know beforehand what it is that the user will be typing in. I mean, we can control it up to a point by using the prompt, what we are asking the user to do. But of course, the user doesn't have to. Well, we can't force the user to follow those instructions. So that's actually a topic that's going to come later on. I think it's lesson 10 or lesson 11 even, how to recover from unexpected user behavior or unexpected program behavior even. Well, anyway, the point of all this, input doesn't hold any magic abilities to predict whether there was text or numbers typed in on the keyboard. So it just presumes that everything that is coming in is text. And if we have numbers typed in instead, then we have to make adjustments in our code, and the technical term for that is, of course, changing the data type. And remember that if you need to change the data type from this user input, if you know it's going to be an integer number, you use the int command. If you know it was a decimal number, you use the float command. And if you need to transform a number back to text, you can use the str command. So you can turn numbers back to text, and this may have a few practical applications. So such as if you wish to treat numbers as if they were text. So if you needed to, for example, join a number to some piece of text, usually that would not be possible since you can't join text and numbers. It doesn't make sense to add up a piece of text into a number. But if you convert the number to text, then you have two pieces of text, and if you are joining them together using the plus sign, it will simply merge those two pieces of text. And that's more or less the usage for whenever you might be using str. And that's pretty much everything we covered last time in about 8 to 9 minutes. So now that we went through that, just as a refresher of what we did, we're going to dive into more text manipulation. So while we did a lot of stuff with text last time, we're going to be doing a lot more with text now. So basically the topic today, text manipulation, how to work with different types of text. And usually the text that we work with is actually text input. So it's input that we ask from the user, and then we have to do something with that input. And this lesson basically looks at the different things you might be doing with text. Okay, so let's once more look at things related to printing. So we already covered various things about print, and the gist of it all is you can print text or numbers. Those are the two data types that we have in our disposal, and print will handle them both with ease. If you have text data, it needs to be wrapped in either single quotes or double quotes. And you can join multiple things using the plus or the comma. There is, however, something that we still didn't cover, which are special characters, or actually they are called escape characters. Well, escape characters is the technical term. So to look at what escape characters are, they are special characters that you might not be able to use normally using those rules that we talked about last time, so that it's text that's wrapped with quotation marks. So it turns out there are a couple of different like special characters. They all begin with a backslash, and using the backslash will enable you to put in these special characters that have some special meaning. So as an example, the single quote character or the double quote character. And if we look at this in practice, so let's open up the code editor and just start to code a little. So So let's try to print some of these escape characters. So basically the thing with these single quotes and double quotes is I have now put my text here in inside these double quotes. And if you remember from the very first week, if the types of quotes that you can use the double quotes, you can use the single quotes. You could also use those special triple quotes. And I think what we went through on that first week was basically if you want to put quotation marks inside quotation marks, you have to use these. You have to use another type of a quotation mark. So, for instance, if I want to put this single quote inside my text output, I can do it like that. So if I have this if I have this piece of text wrapped in the double quotes, I can use a single quote inside, no problem. As we can see, no problem. But what if I wanted to use the double quote? So change that into a double. So now if I go ahead and add this double quote here, you can see the text starts to change color. And if I try to run this program, it's going to throw an error because Now I've used the double quote symbol to mark where my text data is. So I can't put a that double quotation mark inside of this text. So if I was to change these quotes, the surrounding quotes to single quotes, I would be able to put in a double quote like that. Now again, no problem, since these quotes are different. But let's say I really wanted to use the double quotes on the outside and also print this double quote inside the text. So this is where the escape character comes into play. So if I there we go. If I put an backslash preceding this double quote, this backslash is the escape character. It's basically signifying whatever character comes next should be treated as just something we're about to print, and it shouldn't be used to denote text data. And now suddenly, even though I have wrapped this text with using these double quotes, and I have this double quote character inside the text itself, I should be able to print it like that. We can see that's the double quote right there. So this is the use for escape characters. They're special characters that we need to be putting in. That if I want to put in, so these characters that usually have some special meaning, such as this double quote, which usually means it is there to wrap text inside. I can suddenly use it inside the text itself. Okay, let's let me duplicate this and go on to the next interesting special character. So in this table that I showed there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different special characters. And some of these are more useful than others. One of the more useful ones that you will actually need is the new line character. And what the new line character does, just to demonstrate, I'm going to add one more line of print after the new line so you can actually see what's going on. So new line, as the name tells you, is simply an empty line. So this new line character \n, if you print that, it will create an empty line. So that's why I put this last piece of print at the end, so you could see this new line very clearly. We could also add from this listing something that's easy to see, the tab character right here. So the tab character basically just indents text. So we do \t, and then we have to also put something on the right side of this tab character, so we actually see what's going on. So as you can see here, what the tabulator does, it works as in your word processor. It shifts this text to the right, and if you were to put multiple tabulator characters there, it shifts it even more to the right. So the tabulator is used to shift text to the right one paragraph spacing at a time. What else? There is well, there is of course the backslash character itself. So let's borrow this line. Okay, here we go. So the backslash character itself, if I only type in a backslash, that's the special escape character, meaning something that's coming on the right side is going to be treated differently. So if I just hit one backslash here and try to run, I end up with an error because I'm not actually specifying an escape character. So to get an actual backslash, we need two backslashes. So the first backslash is the escape character, and the second one is the actual symbol that I want to print. So as you can see, we have successfully printed a backslash. So to print the backslash, you actually need to type in two backslash symbols in the code, because just the single backslash is used as an escape character. Okay, finally, there's a couple of things here, such as backslash A, which is a bell character, backslash F, which is a form feed character, and backslash R, which is a carriage return character. Now, you might be wondering what these are and how useful they are. Well, it turns out they are not very useful for us, but they still exist. And the reason why these exist is actually due to some history. So this is only a curiosity. Don't get too hung up on it. But if we think about what was the original teletype printer, what was the original interface sometime in the 1950s, 1960s that we used to interface with computers? Well, back in the day, we wouldn't use screens because televisions were actually expensive. So these terminals that computer programmers or people who used computers would use were actually teletype printers. So it was a typewriter that interfaced with the computer. So all the commands you would be typing on actual real paper. So this machine is an actual typewriter, and you're writing computer code commands on paper, and then the when you write one command, then and you press enter, then whatever is the result of that command or computation or whatever it is that you're doing, the result of that will be printed on the same sheet of paper. So the paper was used instead of a monitor. So this is pretty much the reason why there are funny escape characters such as a bell or a new line, well, a bell or a carriage return. So a bell is basically used for when you're typing with your typewriter and you're coming to the end of the line, the bell rings and tells you that you're about to run out of paper. Carriage return means basically once you are at the end of the line, you're at the end of your sheet of paper, you want to go to proceed to the next line, and you need to move the carriage back to the position where the typing head is at the leftmost part of the paper. So that's what's called a carriage return. We're literally returning the carriage that has the paper in it to its correct position to start a new line. And this may sound really old and really funny, but it does have some consequences as to how computers work. And just to illustrate that this sort of backwards compatibility does still exist, and it has some certain consequences. It is actually possible to print one of these printer or typewriter related escape characters. Particularly the bell character is probably one of the easiest. Now, I'm not sure how well this will work, if you will be able to hear the sounds that I hear. But basically, depending on which prompt you are using, this usual white idle prompt does not do the correct thing. So I pulled up this black box instead. The Python interpreter is the same. It's just a slightly different interface. Don't worry about it. And this is purely just for this one demo, which is only a curiosity, and we shouldn't get too hung up on it. So if we remember this bell character, it's \A. Okay. So if we go to a terminal that knows what to do with that sort of character, and we try to print that character, so it's \A, and if I press enter now, you will actually be able to hear the terminal giving that bell sound, which for me is that Windows notification tone. Now again, I have never done this demo, so I don't know if you guys are able to hear my sounds. So like, I would appreciate if somebody types in the chat if you're able to actually hear that or not. Because if you were not able to hear it, then amazing. So this demo was not in vain. So again, this is more of a curiosity. It's nobody is ever going to in practice use these bell sounds for anything productive or anything. It's just something that happens to be there, and the history comes all the way from the 1950s, from when we used to interface with computers using those teletypewriters. Well, anyway, the takeaway from this is the escape characters. Some of these are more useful, such as this single quote character, double quote character, the \/ character. The tab character and the new line character also will be useful when formatting text. Otherwise, for example, this carriage return or the bell character, they are not really going to be of use. So, but it's just an interesting curiosity of how things work. Okay, so to recap, this \ character is a special escape character. So if you need to say there is something special that we want to print here, something that you wouldn't be normally able to do, because, for example, the quotation marks mean that there is literal text that you want to be working with. So that's why you cannot simply put a quotation mark in the middle of the text where it clearly does not belong, or at least you won't be able to put it wherever you want. So the New line character \n is very useful. It signifies a line break. And this tabulator character indents your text, so it moves text to the right. And one of the things to remember, this new line character is useful, but you also always get a new line automatically because the print command will always put a line break at the end of the line automatically. To demonstrate this, we could also remove it. So if we were to do something like this, I'm just going to quickly comment out this whole demo and continue from here. So to demonstrate that the print usually makes a new line at the end, so here is just a normal print command, and it should make a new line at the end. Like this. So with this special end equals something, we can tell to the print command to not put anything at the end of this line. And just to demonstrate that it works, I'm just gonna put one more print at the end of this program. So what I expect now to do is this first print will print normally. This will print one line. This next print will print one new line, but at the end it will not. So this text will appear on a new line because there is a new line at the end of this first print, but it will not create a new line at the end. So this text end of the program should actually follow this middle sentence here. So if we take a look on the right, so that's exactly what it does. So it says here print usually puts the new line at the end, which it does for this sentence. And here in the middle is unless we tell it not to. And then we proceed to the last print here, which is end of the program. And if I take this end command away, you will see that we should get 3 lines of text in the console, which we do. So now everything is on its own line. This again might be useful when we want to print text. It's usually beneficial to know how to print stuff or how to print empty lines. Okay, let's comment out this part as well and continue with the presentation. Here we are. Right. So again, working with text, one of the things in Python that actually works slightly differently to many other languages. So if Python is the first programming language you learn, this is where I should voice a word of warning. So this is actually in many cases a bit different to to many other languages. And similarly, if you come from a background of doing programming with another language, this is where you will probably make mistakes because for Python it works slightly differently. So this we know from last week, actually, this string concatenation. So if you want to join two pieces of text together, you can use the plus operator. Alternatively, placing two strings next to each other makes Python concatenate them automatically. So to demonstrate this, let's take these two lines. So let's do a little bit of string mathematics. So ham plus stir should equal hamster, and car plus pet should equal. Actually, let's leave the plus sign away, since I already said, like, just placing these strings with nothing in between should make Python join these together automatically. So as you can see, joining those two individual words either with the plus sign or just placing them next to each other. So much similarly to the plus sign, we could also use the multiplication, this multiplication operator. If it makes sense to use the plus sign for text, so adding one piece of text to another, it should also make sense to be able to multiply them. So in that, we should probably need a couple of variables. Hang on. Again, I'm just going to comment out the previous thing that we did and start off from a clean slate. Okay, so let's have a variable called word1, and that's just going to have 2 letters in it. Another variable called word2. And now I'm just going to use these pieces of text to construct the word hamster. So to do this, just going to put everything, all these string mathematics inside a print statement. So we should do something like word1 plus word2, and that should equal 1 hamster, right? So what we can also do is we can also multiply So let's say we have this first word, this ha, we add it together with the hyphen here, and then we multiply this whole thing by 3. And for neatness, we're just going to add one more ha into this and see what comes out. So now our print is effectively stuttering. So inside these inner parentheses here, we have this one variable that contains some text. So we can join it together using to this other piece of text that just contains this hyphen using this plus sign. So everything that's inside these parentheses is text. And then if you multiply the text by 3, we end up with ha dash ha dash ha. So that's what's forming the first part of this printout here. And then the rest of it, just word 1 plus word 2 forms the final hamster here. So the takeaway here is that just multiplying a string with a number will give you whatever text was inside your variable, or whatever text you have inside these quotation marks. In this case, times 3. You could of course do times 10, and it would print out 10 times, and so on and so on. So for instance, simply x times 10 is just going to give us 10 x's in a row, which is a neat way of multiplying individual characters or small pieces of text from left to right. This again something that not all programming languages have inbuilt. So this is a neat thing, very indigenous to Python. Okay, moving on to the next topic. So with the plus sign and with the multiplication sign, we can do a little bit of text manipulation, but so far we have just been adding pieces of text together. And sometimes we want to take away or take a small piece from some text input or some text variable and use it in some other context. So that's when in Python we use a term that's called a slice. So a slice is a piece of text. You might imagine we have a big pie and we're taking a slice of it. So a piece of text taken from a variable or input that contains text. And slices are marked with the square brackets. And the easiest way to use slices is to take individual characters, individual letters inside the string of text. And then we, in that case, what we do with these square brackets is we put an index number inside them. And that index number is just a number that denotes the position of that individual letter or that individual character. So in practice, this would look a bit like this. So if we once again take our hello world example here, and we start printing individual characters from this. So to print the whole text, we would just do print text, which probably everybody remembers already. But if we add some square brackets and a number inside, we're going to get individual letters. So the 0th character from this text is the first one, H. We take the next letter, the letter that's at index number 1, that's going to be E. If we copy this around a little bit, 2, 3, and possibly let's go all the way to the 4th index, then we get the whole word hello. So what we're doing here is we're taking individual letters from this text using these square brackets. And notice that the indexing, this numbering, starts from 0 because, well, computers calculate in a way where numbering starts from 0. That's just how it works. In most programming languages, indexing starts from 0. That's not to say it's the case in all programming languages, but for most. And it may seem unintuitive, but in some cases it's also it's just how it works. Sometimes even in human terms we start counting from 0. So if you think about when did this millennium start, so if you think this millennium started in the year 2000, you would probably be in the residing with the majority. So in that case, our decade, or when this decade from starting from 2010 started, then we are also starting from 0. So or actually, since I've just realized it's the year 2020, we are at the beginning of a new decade now, and we're starting to count the decade from the year 2020 instead of the year 2021, much like the millennium started in the year 2000 and not in the year 2001. So this way of just starting to count from 0 instead of 1 is well, it happens to be the practice that's very common in computer science. Maybe a quick word on how this indexing actually works. So what the index is simply a number that shows the position of the individual letter. So over here on the left, the leftmost position you can go is 0. If you go to position 1, you're already at the second character or second letter. At position 2, you're at the third letter, and position 3, you're at the fourth letter. Interestingly, you could also count backwards. So if you were to do -1, it means the last letter. -2 means the second to last. -3 means the third to last. We can actually try this out by modifying our program code just now. So let's also print a few letters from the back. So let's do text -1 and text -2 and so on. So as you can see, this last printout for these last two printouts for text -1 and text -2 got us the letters D and L, which happen to be the last letters for hello world. So if you do negative numbers, we are then going backwards. So taking letters from the end, and this can be beneficial in some circumstances. So these index numbers are counted from left to right from the beginning of the text. The only exception to this left to right rule is the negative number as an index. So if you use a negative number, it means we're going backwards from the end of the word. In this case, it means right to left. But bear in mind that the negative number is just an index from the end, as the positive number is an index from the beginning. And that negative number has no other meaning. It's just a way to reference those same letters, but just in a different direction. So in other cases, text in Python is always processed from left to right. And even if you are using the negative index, that doesn't change. So this will be important when we get to the next slide, but just to inform that even if you are using the negative numbers, it doesn't change the way that Python processes the text, which is always from left to right. The negative number is just a way to reference one individual letter inside this string of text from the end. So this is something to keep in mind. And this is actually a way you can make mistakes and wonder why it doesn't work. So that's why I'm just pointing it out right now. Okay, so next up, in addition to individual letters, we could also take longer slices that have multiple letters from the same string of text. So we could specify a starting and ending index, so we can specify two numbers instead of one. And if we do that, there needs to be a colon separating them. So this these two numbers separated by a colon basically mean the starting index and ending index. So let's see what this text from 0 to 5 would mean. So I'm gonna go a bit back. Let's leave. So this was the example. So we have this variable text and we want a slice from the 0th index to the 5th index. And let's see what this prints out. That prints out the word hello. So if we look at the original text and if we try to remember how the indexes worked, if I pull up the picture right here as well, the first letter here is at index 0. Second letter here is at index 1. Third letter is at index 2. Fourth letter is at index 3. And the final letter is at index 4. Now, this may be a little counterintuitive, but when we are specifying a slice like this, how this works is that on this left-hand side of this colon, the starting index, this is always included in the slice, whereas the end index is never included in the slice. So what this means, it's a slice from 0 to 5, from the 0th index to the 5th index, but this 5th index is not taken into the slice anymore. And that's why it only gives us the first 5 letters instead of this 6th letter, which would happen to be an empty space. Similarly, if we think about just taking the first the text up to the 4th index, we would end up with the word hell instead of hello. So even though there are 5 letters in the first, if we want to print this hello from this string of text, even though there are 5 letters and you would think, okay, its index is 0, 1, 2, 3, and 4, this will not get you the whole word. So you have to put +1 into the end index like that. So it's from 0 to 5 because the end index is not included in this slice. Then to make this a slightly more complicated, you don't actually have to put in a number into the space where the index goes. You can also leave it blank. So if we look at how that works, so let's leave this first 0 just blank, so there is nothing on the left hand side of this colon, and see how this program now works. If we look at the printout on the right, nothing changed. So if we leave the starting index here blank, the interpreter will just start from the beginning of the text. So if if this starting position is left blank, we start from the beginning no matter what. If I put the 0 there, the 0th letter is the first letter anyway, so that's why this makes no difference. If I leave the end index unspecified, so if I leave this blank, it will simply mean going all the way to the end. That's why we get now hello world, the entire text that we started with. So if the start index is left blank, the interpreter will start from the beginning of the text. If the end index is blank, it will stop at the end of the text. And actually, we can also leave both of these blank at the same time. And this will not change what we had here previously. This will just mean start from the beginning and end at the end. This will give you a copy of the original text. Sometimes this also can be useful. Probably not for text, but there are some cases where the same kind of notation works, and you may find this useful. But that's in a future lesson, sometime far away in the future. We can use negative indexes as well in the slices. So just as with individual letters, we can use negative slices for the indexes. So let's say we wanted from this hello world text, we wanted to get all of these last five letters. So how would we do that? Well, we would specify that we want to start from the 5th to last letter, and we want to end at the end. So I'm just going to leave this blank now. And that's how we get the last 5 letters. Notice that because this end index is it's now blank, but usually the end index is not taken into the slice unless it's blank. If I was to specify here the 0th, or well, actually like -1, this will only give me a partial result. So this will not give me the last last letter here, because this end index specifies where the slice should end. So if I want the final 5 letters, I need to leave this ending index blank, like this. Similarly, if we think about like how could we fix this, do we have to leave it blank? So if it's now at -1 and we're not getting the full word here, world, might I just like might I just change this -1 to a 0? Well, this turns out to be a really bad solution because it will not work. So what we get then is nothing. We get absolutely nothing. And this is basically because of this table that I showed that shows how the indexing works. So here 0 is at the beginning of the word. And in this case, -5 would be, well, wherever it is, counting backwards from the end. So saying something like -5 to 0 doesn't make any sense, because 0 is at the beginning. So this is the end, and 0 would be where we want to end, and it's at the beginning, whereas -5 or minus whatever is already past the start point. So what we're saying here is like we want to start from the -5th position and we want to end at the 0th position. So basically what we would do is start from here, from this letter, and go all the way back and end all the way back here in the beginning. But as I mentioned earlier, in Python, when we are manipulating text, we're always processing it from left to right and not right to left. So that's why this slicing would not work, because the end value here, 0, which would be this letter H, this is already beyond our starting position, which would be -5 and this W. So we can't start from this W and move forward until we get to this H, because we're only moving from left to right. So this indexing does not make any sense. So this is the kind of danger that there is when it comes to these negative slices, and why it's important to remember that we are only going from left to right. It's impossible to go from right to left when slicing text. So the correct way to get the last 5 digits is to say we want to start from the -5th position and end at the end of the text, like this. Again, so remember that the text is processed from left to right. If you use negative indexes for slicing, you must specify the slice from left to right. So for example, saying something like this. So from -11 to -6. So this numbering has to be from left to right. So -11 is before -6, so that's why it's on the left hand side. You can't put it the other way around, as I just tried to show. Otherwise, it will not work. You will only get a blank. You will only get empty pieces of, or you will only get an empty line as a result. So the slices give you all the letters in a piece of text from left to right. So what if you don't want all of them? What if you, let's say you only wanted every other letter? This is where something called stride comes in. So stride is something you can also specify into these square brackets, and again using the colon as a separator. So this is a third number that basically says, well, the number 2 means every other letter, number 3 would mean every third letter, and so on and so on. So if we wanted to say we want the remaining 5 letters from this text, but we only want every second of them, then we would specify, put one more colon in here and specify the stride as 2. This stride is not compulsory. You can leave it out, but if you must specify one, then we have to put this extra colon here, and then we could see what comes out. So as you can see, we are only getting every other letter from this text. So we get the W, then we get the W, then we skip the O, we get the R, we skip the L, and finish with the D here. Notice again that we can leave these start and end indexes blank. So if maybe I want a copy of this whole text, but I only want every other letter. That's how I would do this. So I leave the starting index blank, ending index blank. So I just want a copy. And then we select every other letter from this text. And as you can see, we selected, it printed out every other letter of the text. And of course, even in the stride, we could use negative letters. So in this, usually the stride is defined as 1. So 1 just means everything is as usual. 2 means every other letter. 3 would mean every third letter. So here in the stride, we could use negative numbers as well. So this has a particularly interesting use. So -1 basically means we are traveling backwards. Now again, even though now the stride specifies that we should go backwards, we're still processing the text from left to right. So even if you are going backwards by specifying this stride as a negative number, we're still going from left to right. So if we were to use something like a slice here, let's say it's from beginning to end, or actually let's say it's from let's say it's from -11 to -6. So we would want to get the word hello, because I think from counting backwards from this D, the last remaining letter here should be at 11. So this should get us hello. Well, hello backwards. Well, actually, it's not giving us hello. Let's see what's wrong with this. Yeah, so this is now another example of why this is hard to sometimes grasp. So even I got it wrong. So if we're going backwards, we suddenly need to go a different direction. So is it maybe 12 then? Here, there we go. There we get the whole hello. So if we're now going to the other direction, this stride changes the travel. So now, whereas -6 used to be the place where we end, it now has to start because we are going backwards. So the stride specifies where we are going, what direction we are going, and how many steps we are taking. So again, the idea that we're going from left to right, except in these couple of cases, this can be a bit confusing. However, though, of course, we could do some tricks to try and make more sense of this. So let's say we wanted to get this text "Hello World," but well, so let me create this variable called reverse, and I'm just gonna put whatever is in text, and I'm just gonna make a slice. So a copy of this, but backwards. So now if we go and try to print this reverse, we get the hello world in reverse. And let's say we now want these last remaining five letters out of here. It may be easier to just specify. So we want the letters from the -5th position all the way to the end, like this, like that. So as with any data, we can just make this code a little bit clearer, so we don't have to put all the parameters here inside the same slice. We can just manipulate these slices, this text, one little modification at a time. So we first think of what is the reverse of this text, and then out of this reversed version we take the portion that we needed for this, and for here we only have a very simple slice. So this is a bit more readable in terms of putting everything on the same line, just to try and make this a little bit easier to comprehend. So the first line reverses this text, and the second line prints the final 5 letters out of it. And of course, how this slice worked, we start from the -5th position in the text, and we end at the end, because we left this end index blank. What else about text manipulation? One small reminder for all those who have programmed in some other language. So these indexes, these slices, cannot be used for altering the text. So let's say we had some piece of text. So let's say we have this variable called shape, and we have a value inside it that's going to be square. So we have something that's square shaped. And I'm just going to type it out to the editor right now. Yeah, so we had shape was square. So let's say we want to turn this word into another word that's somewhat close. So let's turn square into squat. And if you think about, okay, these two words share a lot of the same, so could we just like take the beginning of this word and change these last two letters? So maybe we should just say, okay, this 1, 2, 3, 4, sorry, 0, 1, 2, 3, fourth letter here should be a T, like that. So in some other languages, this would work. This would change this individual letter to something else. But if we try to run it in Python, going to say no, you can't do that. So you cannot modify these pieces of strings, pieces of text by using these indexes or slices. Well, I mean, you can, but you can't simply say you should. You cannot simply tell some individual letter from a piece of text should be something else. So this is not allowed. So what you can do though is you can use the slices and the plus operator to concatenate uh, things. So what we would want. Actually, let's create a new variable. So the new word would be the first 5 letters from or the first 4 letters from this word square, and then we add another T like this. And if we do a couple of prints to see what the word used to be. Actually, this is in the wrong place. Here. So we print this word here, and then we print the new word. Like this. So instead of changing what this variable shape contains, we're more or less creating a new variable or creating a new piece of text using this plus operator and this slice of the old word like that. So now we can see how we changed from square to squat, and we accomplished the thing we wanted to accomplish. It's just that we can't change individual letters from one piece of text. It's something to bear in mind. So one final thing for this time, and it's paradoxically about numbers, because this is something that you will need in the exercises. So even though a lot of the stuff that comes from the keyboard is going to be text, you remember how the text input from the keyboard is converted to numbers if you type numbers instead of text. So for example, if we were to take some piece of text that contains a number, here. So this is now text instead of a number because it's wrapped in these quotation marks, and then we convert it into an integer number afterwards. So this is the same as asking a number using the input command from the user. This is just for demonstration purposes. All right. So the one thing to remember about this, of course, is that the int command doesn't work with just anything. So if you don't put a number inside this int command, it's not going to work, and you get an error. So again, if you ask for input using the input command and then you don't type in a number, you will end up with the same error. So the computer is simply saying, I cannot translate this non-number into a number. The thing to remember about this is, what if you have decimal numbers all of a sudden? So what if you had a number like 2.999 and we convert this into an integer number? What comes out? So we see that from this number that's almost 3, 2.9999, we get the integer number of 2. So this is slightly wrong. I mean, it's not wrong. There is a 2 in it, but surely this is more closer to 3 than it is 2. So the integer, so this int command that changes the data type from text to or other types of numbers to a whole number doesn't round anything correctly. So in order to do this, well, let's first put this. Well, actually, let's not. In order to round it correctly, you need a command that's called round, unsurprisingly. Now this should turn more towards 3, which it does. So to round numbers to a specific decimal point, you need to specify how many decimal places you want that to be. So let's round this to 2 decimal places like this. So the actual command for this is now, it's round the number that you want to round, comma 2. 2 meaning 2 decimal places. If we don't specify a decimal place here, so we don't have a 2, we don't have a comma here, it rounds it up to the nearest integer. So if we play around with this to see what happens, so if we just round something like 32.0, we should expect this to be 32. And let's round something like 3.14149, which I think is the first 5 digits of the constant pi, and we round these to 2 decimal places, and let's see what comes out. So the first number 2.999 is of course 3 because we didn't specify a decimal place here. The same with 32.0. It's rounded to 32, and here 3.1414 comes out as 3.14 because this is up to 3. That's what the number is, up to 2 decimal places. If we wanted 4 decimal places, the result would be slightly different. So here we would get 3.1415 because 1, 4, 1, and the 9 at the end bumps up this last remaining digit here. So right, that I think is most of the stuff that we really should cover today. So, and most of it was on the topic of text manipulation. But of course, when it comes to text, there are some things that you have to take into account if there are numbers involved, and one of those things happens to be rounding numbers. So, and when we're rounding in Python, we use the command called round. And with those, with these, well, the takeaways from these examples should make it possible to do the exercises for what is lesson 3. And I think that concludes for today. I'm going to turn off the recording. If there is something that you want to ask or clarify at this point, this would be the time. So I'm just going to turn off the recording real quick.